I guess we should start in now. All right. So, hello everyone. I am Harsh. I'm the DSC lead of ADG ITM and also the co-founder of DataQuest. So, let us begin today's session. So, alright, we are now gonna start off. So, every attendees are requested to keep their webcams and mics off during the session. We have volunteers in as well, so who will be like keeping a constant watch on everyone, and if anyone has any queries, they would be answering it. So, moving right, we have so about us and who are we. So we are basically a community driven towards connecting out with people and enhancing the technologies through community building. Our main focus is to allow everyone to connect to us, and we believe to build successful products in future with the help of our own very communities. So uh, feel free to join us on our Telegram groups and connect to us. In case you like our session and really want to have more like these sessions, don't forget to tag us on our social media handles using DSC, ATG, ITM, DataQuest @tags and hashtags. So who do we have today in the house? So today we have Moez Ali along with us. So Moez is the creator of this amazingly fast machine learning library, which is Pycaret. So Moez created this libraries a few years from now. So in case you don't know much about Moez, so we'll be even sharing his LinkedIn profile. You can connect out with him. Moez even had a recent session with the 4x cattle grandmaster Abhishek Thakur. So you could even have watch his session out there as well. He has previously worked at Pricewaterhouse. He is also was a research assistant at customer analytics at Scotiabank and has worked in many firms. So now we'll be handing over to Moez for today's session. So Moez, it's all yours now.
Thank you, Harsh, for introducing. Let me share my screen and
Yeah, sure. I am pausing it. I'm turning my screen off.
okay, can you see my screen?
Yeah, Moez, perfect.
Okay, perfect. Okay, you want to go on mute? I hear a lot of feedback noise, Harsh. Okay. All right. Hey everyone, thank you for joining today. Thanks, Harsh, for introducing. As you know, my name is Moez Ali. I'm an analytics leader. I work for PwC Canada. I deal with a lot of technical and engineering stuff, but I'm also a very passionate data scientist by night. Very active in open source community, with most recent contribution being Pycaret that I open sourced in April 2020, so 4 or 5 months ago. I don't have a technology background per se, but I'm by trade I'm a chartered accountant, not practicing anymore. Obviously, have been in this space for last 3 or 4 years, I would say, actively, and have lived and worked in 3 different places, but has mostly had mostly done reporting and analytics role in healthcare and public sector. These days, based in Toronto, working for PwC. Pycaret takes a good amount of time in my life, and I'm trying to juggle between the academics, Pycaret, and my full-time job. Very active on social media, primarily on LinkedIn. Here's my LinkedIn profile in case you'd like to connect. very active writer on Medium as well. So here's my Medium link. If you go there, you would see that I have written tons of articles, or I would say tutorials on Pycaret, and primarily integration of Pycaret with different technologies like AWS, GCP, Azure, Power BI, Tableau. So feel free to follow me on Medium. Here's my Twitter link as well. Okay, so for today's session, here are a few important links that you need to know. Our official website, pycaret.org, has everything. So your best place to go to when you have a question or you're trying to find something in documentation is definitely website. If you'll message me on LinkedIn, you wouldn't get as fast response as you could get an answer from our website. Okay, so keep that in mind. This is our GitHub page. If you have issues, there is a community there that is actively responding to issues. Feel free to open an issue there. It's still a better way than sending a message on GitHub if you have Pycaret specific issues. My LinkedIn profile, not my LinkedIn profile, the company's page on LinkedIn to follow if you are interested in upcoming updates of Pycaret, a YouTube channel, and the same Medium. But the most important link in this presentation today is this GitHub link, which is github.com/pycaret/pycaret-demo-dataquest, because everything that we are going to do today is uploaded on this GitHub repository already. So I'm going to pause here for 30 seconds in case you want to copy this link. It's not hard. github.com/pycaret/pycaret-demo-dataquest. This presentation and all the notebooks, there are about 5 or 6 notebooks uploaded on this repo. And if somebody please want to type it down into chat so other people can just go to the link if they want. Okay, let's get started. Okay, so this is the machine learning life cycle that I'm sure many of you have already seen. It starts from business project, business planning, gathering data, and it ends with deploying model and production, which you see on your far right side. Today, what we're going to do is we're going to zoom into this process, which is basically integrating your data, and that begins with training your machine learning models, hyper-tuning them, or on-sampling them, and all the other bells and whistles that goes into a typical supervised machine learning training process, right? Which normally ends with deploying a model in production through a REST API or through some kind of endpoint. Okay, so we're going to zoom into this process. Anything on the left is pretty standard, like ETL, and obviously it's not. It's if you think from a perspective of real life, this would obviously take a huge amount of your time building ETL pipelines and all that. But obviously, building ETL pipeline is totally independent of model training, right? So today we are only talking about model training. Okay, so this is a high-level diagram. But if I zoom into this side of a model training process, there would be something called granular ML lifecycle, and which looks like something like this, right? You have a business problem, you have an ML objective. Basically, your training workflow starts right here when you split your data into train and test, right? And then there are multiple ways you can deal with it. You can set up a good cross-validation environment through K-fold, stratified K-fold, or time series split, or whatever your problem is, right? But the point being that this is where a typical supervised experiment would distinguish itself with other unsupervised or anything else is you'd always have a train test split, whether you just want to do a plain vanilla train test or whether you are even doing a cross-validation, you still end up doing a train test, so that then you have 3 sets, right? Some people call it validation set. Okay, then you have to handle data types for numeric and categorical columns differently. You do have to impute missing values or create transformers that would impute missing values on unseen data in case you're planning to put your model in production. And you have different kind of encodings to deal with categorical data. You have different kind of scaling based on the kind of algorithms you are using. Some of them require you to have the data scale. Some of them is just nice to have. It's not required. So you have different kind of scaling. You have different kind of transformations. you do feature engineering, you do feature interactions, feature selection, you do zillion other things. And then you finally start your model training process. And then you set up some kind of cross-validation environment so that you can track the performance, and then finalize a model, right? But to do that, you do a couple of things. You also do the hyperparameter tuning. You try different methods of on-sampling, such as bagging, boosting, or creating voting classifiers, or maybe stacking and things like that, right? And every time you're doing this, you have to keep track of performance. And what I mean by performance and parameters, right? And what I mean by that is the only reason you are doing so many iterations of model is so that you can, one, either improve the performance of your model that goes into production and starts predicting on unseen data. So the reason you're doing all this is so that you can choose the final model. And to choose the final model, you have to keep track of not just the model itself, but their metrics, their parameters, because in this entire exercise, the challenge is you do it on repeat basis until you find that one model, right? The problem is you generate a lot of metadata, right? And what is that? You have hyperparameters of each model. So if you think a model like XGBoost would have 35, 40 hyperparameters of a plain XGBoost, right? Logistic regression would have 6, 7, 8. But you're generating a lot of metadata in terms of parameters, in terms of metrics, not just one metric, but maybe you're keeping track of accuracy, AUC, recall, precision, multiple metrics across the fold, across the time interval that how long you have invested in tuning and how much the performance has improved. The point being, it is a lot of data to keep track of manually. Some people would do it on Excel, like some people would take an output from notebook, do it in Excel, but there is no one right way to do it, right? Now, what is Pycaret? So Pycaret is an open source low-code machine learning library. When we released it in April, it was just a Python-based library, but now with 2.0, it's an end-to-end model management tool, and it helps you automate your machine learning workflows in Python, right? So, so the most basic or common use case for Pycaret is rapid prototyping and deployment of ML pipelines. And as we go through the demo today, you would see why I call it, or why I stress a lot on fast, rapid, words like those, because it's really fast. You get from and the biggest thing, if you think here, is if you can iterate faster in machine learning scenarios, that means whether in terms of processing time or whether in terms of your coding time or anything, right? If you can make it faster, that means you have more options or more pipelines to you can evaluate more pipelines or more options in the same time as we're doing in past, right? So if you can save some time in the machine learning workflow, that's like a real gain. Okay, so three things that I would always say about Pycaret as a creator: that it's extremely easy to use, and it's not a coincidence. So the library was designed at the time 1 year ago, and at that time I had no background in Python or computer engineering or anything. So it was, if you think in many ways, it's a design from a business user of how I would like to see machine learning library if I'm using it. And obviously I am not only the creator, I'm also a consumer of this library. I use it at work as well, right? It's a productivity tool and it's business ready, and none of them is a coincidence. It was a very deliberate or conscious step that we have taken to make this library extremely simpler, and as a result of which, this library is a little bit different than how other OOP libraries like object-oriented programming works in Python. So it's different than typically any other library that you would see in Python. It is more closer to how you would write code in R, so it's functionally typed, right? And the reason is so that we can stay or continue to stay as simple as possible. And now we are in the phase where I have a team of a lot of computer engineers and technical people who are re-engineering the backend of Pycaret, so as to keep the functionality same, but they are optimizing the backend so that we can get more developers from community in future to help us grow the library, right? So it's kind of a reverse in that sense, very non-conventional. It can help you with data preparation, model training, hyperparameter tuning, analysis, selection, and experiment logic, right? So instead of just talking about it, What I'm going to do is get into demo in the next 2-3 minutes. But before we do that, 2.2 is coming. So maybe in 2 or 3 weeks, it's in the final testing stage. Pycaret 2.2 is the next release, and there are a couple of big improvements in 2.2. Number one is we are now allowing GPU-enabled training for at least 9 or 10 supervised algorithms, right? And we are using Rapids and QML backend to do that, and it's really powerful, right? And if you don't know a lot about GPU versus CPU training, I have recently posted on LinkedIn the benchmark timing, and trust me, you get a lot faster training on GPU. Okay, we are also introducing, so at the moment you can do hyperparameter tuning in Pycaret, but it is just a random search. So those of you who are familiar with sklearn, it's a random grid search, right? But in next release 2.2, we are also integrating 5 other libraries. That's all you have in Python as of today in terms of hyperparameter tuning. We are integrating Optuna, HyperOpt, Scikit Optimize, Tune sklearn, which basically use RAID, which is a distributed processing system. So not just that you can train models on GPU, but you would also tune them on GPU. And if you are using certain search algorithms, you would also train on GPU on a cluster, right? And this is a really powerful integration, because if you have worked with these libraries in past, like Optuna or Scikit Optimize, you would realize it's a little bit different than how you would work with scikit-learn. So what we have done is we have taken our time and efforts to unify this API. So basically, it doesn't matter whatever method you want to use, Bayesian, random, or any other method from Optuna, HyperOpt with early stopping or whatever, right? There are 15 different combinations. I don't even remember all of them from top of my head. But for you, it doesn't matter. You just have to specify the name. Obviously, you should understand what you are doing. That goes without saying. But in terms of coding, it's now a unified API, which I think is great. 2.2 is more about flexibility and customizations as well. So if you would see 1.0, 2.0, and 2.1, it wasn't customizable to that extent, but the next version is the highest level of customization. That means you can customize anything and everything. So if you don't want to use our transformation pipeline, you bring your own transformation pipeline and just use model training from Pycaret. If you just want to use our pipeline and train the model on Spark, you can just use our pipeline for transformations and train in your environment if you want. If you want to code your own metrics, you don't want to use accuracy AUC, you can pass in your own metrics using some functions. Obviously, we have provided those functions. Bring your own model. You are no more limited. In fact, this was never true, but now more than ever, you can simply wrap anything with Predict API and it would work with Pycaret. So basically, think Pycaret about a replacement for boilerplate code or like a template instead of training 10 models, right? There's a huge performance gain, and we have reduced memory footprint of Pycaret, as a result of which it is now able to scale well on a single machine relative to the past. Now, if you have a data set of 500 GB and you cannot fit on disk, obviously you cannot work with Pycaret, right? But previously, even if you can fit on disk, you would have memory failures. We have optimized a lot of it, and hoping that it would allow you to at least work on relatively larger data set now compared to past. Okay, and in the background, this is the most exciting thing. In the background, we are also working to allow Pycaret work on not just single machine all cores, but also to scale up on clusters. So Dask is a framework to work on a multi-machine parallelization, and we are working towards that. So that's our end goal, to allow Pycaret to be used in an environment where you can train models on scale. Okay. Getting into demo, so this is the GitHub link where you can get these notebooks. There are 6 notebooks. I'm going to go through the first one, which is classification. So this is the notebook. Okay. Pycaret 2 classification is the name of notebook. First cell I'm running here, utils import version. Just to check the version, the last stable release is 2.1.2, right? And how do you install Pycaret, by the way, is pip install Pycaret. It's not on Conda because there are few dependencies which are not on Conda yet. For example, XGBoost is, I think, not on Conda yet, right? I'm not, yeah, XGBoost, I think. Anyways, this is the stable release. You can either do pip install or you can build from source from our GitHub. It's up to you. Pycaret has a small data repository as well, which basically means a bunch of CSV files on our GitHub page, right? And the reason we do that is because in all the demos and everywhere else, I don't want to circulate CSVs or upload CSVs on multiple tutorial repositories, right? So there are some 40, 50 toy data sets that are uploaded on our GitHub. We try to keep them updated. And also, if you have some toy data set that you would like to submit to repository, feel free to open a pull request. We would normally accept such like new toy data sets as long as there are credits or proper referencing. Okay, so in this case, if you want to check what are those toy data sets, this is the command, like you import get data function from datasets module, and index is basically nothing but another CSV file that I have created, which lists down all the datasets, right? So nothing really important, but you can see that these are the name of datasets, default tasks. So these are all classification datasets. What is the target variable, blah, 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 right? Instances, attributes, missing. Okay, so today I'm going to use this dataset, Juice, which is a very small dataset, 1,000 rows only. But just in the interest of time, I'm going to try to make my point using this dataset. Okay. To get this dataset, I'm doing nothing but get data and calling in Juice. It is basically similar, like if you were to do it, if you were to use the toy dataset repository of Scikit-learn, I think they download it when you download the package. The difference is we don't download all the datasets on your computer, but obviously in order to work with this command, you need it. Okay. Okay, so this is the dataset, as you can see, 1,000 rows, and it's a binary classification dataset, which means that there are outcomes, binary outcomes, so 1 or 0, right? In this case, each row is a transaction from a customer. So you can see, and this purchase column is our target variable. CH and MM, these are the two values this target column has. What is CH and MM? These are the name of juice, right? CH is one kind of juice and MM is, I think, Minute Maid, so two different type of juice. And based on these factors, that what was the price of CH on that day, price of MM on that day, discount, specialty, loyalty, blah, blah, right? All these factors, name, which store, and all these things. Based on this, you have to predict whether the customer would buy CH or MM. Does this have any significance in real life? I would say similar to Titanic. Even if you predict with 100% accuracy, what's the point, right? But I'm not here to discuss that, right? I have to make my point. I have to just show how the tool works, and this is very small, like I said, very comfortable. So don't get stuck in the logic of why we are predicting what kind of juice customer would buy, right? Okay. So first step in Pycaret, in all the modules. So at the moment in Pycaret, we have classification module, which deals with binary or multi-class, right? Regression, which deals with continuous values. Clustering, unsupervised, anomaly detection, unsupervised, NLP for topic modeling, unsupervised, association rule mining. I don't have a certain answer. It's unsupervised or what, right? But it's association rule mining is a separate thing. Okay, so we have 6 modules. We are, at the moment, this demo is about classification module, but basically if you go and see on the GitHub link that I've given, you would find 6 notebooks, 1 for each module, right? And if you go through them, you would realize there was not even any point in creating those 6 notebooks, because basically everything that you are going to see here works exact same way. So it really doesn't matter if it's classification regression. So basically what I'm saying is you don't have to remember anything. There's no learning curve at all. And I don't think so there's any, so it's not something that you would save like a boilerplate code, because you are rather better off writing this every time rather than saving it and copying it. because copying this would take more time than if you were to just write it. And you would see what point I'm trying to make, okay? Okay, so the first thing is, in any module, you have to initialize setup, and setup does some very important things. It basically creates an environment in the background, right? It handles the train test split, it sets the cross-validation strategy, and anything that has to do with pre-processing, such as if your data has missing values, for example, this data doesn't have, but this data has some other problems. You see purchase column is CH and M, so it's not label encoded, right? If you were to just pass in this data set into logistic regression or anything from scikit-learn or XGBoost, you run into problems because this is not encoded here, right? And similarly, if you would see, we have a column which is not encoded again. And if there were missing values, that would also be a problem, right? So anything that has to do with all the steps that are required to prepare your data for modeling, such as imputing missing values, removing unnecessary column, removing columns with very high variance, removing columns with so many values, removing multicollinearity, one-hot encoding, label encoding, target encoding, all those things has to be in the setup, okay? So now what I'm doing is I'm importing from Pycaret classification import all, and some of you would hate me for doing this, and I can tell you, I mean, you are more used to importing a specific function, but I can tell you the way Pycaret works, there is nothing wrong. If you are experimenting in Notebook, there is nothing wrong, there is no harm, there is no loss, there's no compromise of best practice if you were to import it like this, if you are doing experiment. Now, when you promote your code to production, you obviously replace it with something like this, right? You replace it, but when you're doing a Notebook experiment, quick rapid prototyping, there's nothing wrong, okay? If you don't agree, feel free to run this line every time you're running a function. So if you don't agree with this method, feel free to do this. Like for every line, you have to import something. I'm not gonna do that because I believe in this matter. I'm gonna import everything. This code here, I'm running setup. I'm passing my data frame, which is this data variable, target column, name of target column, session ID 123. This is just a pseudo random number so that I can reproduce this experiment. So what happens is there are several places, if you're familiar with scikit-learn, where you have to pass a random state, right? And the problem is if you try to set the seed into the Python environment, it doesn't guarantee that the way sklearn works, it doesn't guarantee that you'd be able to reproduce the experiment unless you pass the random state in each function. So what this session ID does, if you don't pass it, you would generate a random number ourselves. But if you pass it, we'll make sure we take this number and pass into a random state of each function so that you get 100% guarantee that the result is reproducible, right? Okay. Log experiment true. By default, we are not logging everything, but I want to show you something for logging. That's why I'm passing log experiment true and experiment name juice v1. Okay. I'm going to run this cell by pressing shift enter, and you would see what happens. So it's processing. You get this IPython widget here. The first step is it would basically go through the data set, do the profiling, and try to detect the data types. It's not 100% correct because there is obviously so much smart inference algorithm that we have generated to give you the metadata information. But basically it would ask you that this is what these are the columns and this is the type I think these columns have. And if you would see, it has gone as far as detecting the ID column, right? So if you notice, I didn't had to do anything, but there was an ID column in the data set, so it has detected the ID column, and once it has detected, what it would do, it would ignore the ID column. It won't drop it, right? Using Pycaret, what you're going to do is you're going to drop this and other columns that you don't have to use. What we do is you don't need to drop it, you can ignore it, and that means that we'll just hide it during the training process, but when we return the predict model like inference back, you would still have your original data set. But in this case, I don't even need to ignore it because it has detected the ID column. It can also detect the date columns itself, right? And what we do when we detect date columns, there is no date in this data set, but when we detect dates, we extract feature out of dates and we hide the date column itself because there's no value of literal like date column, okay? So in this case, it would give you the inferences, and if you're okay, press enter, otherwise type quit and enter, and there's a programmatic way to override the data types. But in this case, what I'm going to do is just press enter, so that I agree that the data types were correct, right? Just in the context of example, okay? And if I show you the Docker string of this function, it's a pretty huge function, right? And most of these things are very self-explanatory. So for example, train size 0.7, and what it does is you have an original data set of 1070 raws. It has split it into train and test 748 322. That was a ratio of 70 to 30%, right? And anything else that has to do with pre-processing is covered here. So for example, if you want to do a PCA, there is a column, there is a feature called PCA, right? And what I would do is, see, now we have 748 to 28 columns. What I'm going to do, I'll just do a PCA true. You see what happened? 748 to 2, right? Because now if I show you my X train, looks like this, component 1, component 2, right? Let me get rid of PCA and show you what was the original. This is my original, right? So similarly, if you were to create features through interaction, you would do feature interaction is equal to true. And now it might take a few extra seconds, but if you see now 42 columns, right? And if I show you, let me put columns here so that I can show you. You see this, price CH multiply loyal CH, sales CH multiply. Okay, so the new columns are created. Should you have to do it? I'm not going to debate that, right? I mean, this is just multiplying numeric numbers with each other. I don't personally think this is a very important part of feature engineering. When somebody says that you need to focus on feature engineering, what they actually mean is you convert your business acumen and create new features that doesn't exist, right? So this is not exact. This is like feature extraction, more feature extraction than engineering. Okay, but I'm not here to debate that, right? Whether useful or not useful, the point being, you can do that if you want, right? Similarly, let's see one more example. Let's say, what can I show you? Maybe this one, polynomial features. Now if I see, you can see now we have loyal CH. So you would see things like this, right? So it has created polynomial features and then it has created interaction. So now you see things like this. Sale price MM, so that was our original column, to the power of 2, multiplied by loyal CH was the original column, power of 2. How good or bad it is, I don't know, right? Or I'm just showing you, you can do that, okay? Similarly, if you have a class imbalance problem, you can just pass fix imbalance is equal to 2. Okay. Anyways, moving forward, let me just get rid of these two extra things and just do it again. Okay. Now, because you have seen that we are logging the experiment, I want to show you one more thing. It's not mandatory that you start the experiment. So when you pass log experiment true, what we do is at the back end, we are logging everything into a ML flow server. For backend, we use ML flow, which is created by the team of Databricks, right? Very nice tool. So what happened is we are gonna log everything, log all the artifacts, metrics, parameters. But in order for you to see, you have to start that server on your local machine, right? And to start the server on local machine, there are two ways. One way is I open my command prompt, navigate to where this file is. So this is my notebooks, right? In the same folder, you can type MLflow UI. This is one way. I'm going to type it. The other way is you just open a new notebook in the same folder right? And just type this MLflow UI. Same command, but just put the exclamation mark before MLflow UI. Either of way, if you do that, you'd be able to open localhost 5000, and you would see a user interface which looks like this, right? And you can see this is the name we have created, juice v1, right? And here are 5 different, you know how I ran set of 5 different times, right? So under each run, you would see these are all the pre-processing steps that we have seen in the documentation. So basically, it would log all of this plus the entire transformation pipeline. Okay. So and we'll see what is that. Plus other metadata information such as runtime, some codes, so that if you're programmatically doing it, you need some unique IDs by run, by time, blah, 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 right? Okay. So now that we have a server online, even if you don't have server online, it would still log, and then you can, after you finish your experiment, you can start the server. But I wanted to make a point and show you what it is. That's why I started it. Okay. All right. So let's get going. So assuming data is ingested, we have run the setup, everything is okay. This is the information grid that is printed. The first recommended function is compare models, right? And as the name suggests, compare models is basically comparing all the models, right? Because now if you think, we have prepared the data for modeling, we have our train set, we have our test set, we are all ready, get set, go to do fit and predict, right? So compare models would basically, if I shift enter here, you would see this interactive, like this is gonna move on. This is doing is, it is doing a 10-fold training for all the algorithms in model library. What are all the algorithms? Everything that is in scikit-learn, plus catboost, plus xgboost, plus lightgbm, plus all the algorithms in Rapids AI project. So there are about 9-10 estimators that works on GPU. Plus, we don't have those other models, like for example, if you have heard of ngboost, right? We don't have it in our library, but there's nothing stopping you to use ngboost, right? So you can bring your own models as well, because ngboost or genetic algorithms, they work on the same API as scikit-learn.fit.predict. So simply pass your ngboost model, untrained model, into Pycaret, and it will work just like any other model, right? We don't have to list everything in our library, because that would make our base version very heavy, right? If we add everything. But for now, we have entire scikit-learn. We have catboost, xgboost, lightgbm. We have GPU estimators from Rapids. So I think that's good in sense of machine learning. Okay, no deep learning whatsoever. Okay, so if you would see what this is doing is, each row here is obviously is a model. So you can see logistic regression, linear discriminant analysis, rich classifier, header boost, gradient boosting. And these are metrics, accuracy, AUC, recall, precision, F1 kappa, and they are trained by 10-fold cross-validation, right? And it would highlight the best performance metrics. So when I look at this grid, this is a starting point for me. I see, okay, on this data set, in this environment, logistic regression is doing a very good job. If my priority is between accuracy, AUC, precision, logistic regression is doing a good job. But if my use case is, let's say, identifying cancer, I'm more interested in recall, then basically LDA is doing again, right? So this is just a starting point, okay? And this training is basically done using default hyperparameters, right? So whatever the defaults were. Okay, you can also use this compare models function to compare only specific models. So for example, in this case, I'm comparing DTRF lightgbm. So 3 models. Instead of training all the 15 estimators, you can just pass the specific IDs, right? And how do you get these IDs? There is a function called models. These are all the IDs. These are the names, and nothing is special there. Like after a certain time, you would guess yourself what would be the ID of this, right? So naive base is NB, decision tree is DT, support vector machine is SVM, MLP is MLP, rich classifier is rich. So it's very intuitive even in that sense, right? So I don't think so you'd have to remember IDs. Anyways, so you can pass this. So on the GitHub, you would see something like this, whitelist. Recently, we have replaced whitelist and blacklist. We have renamed them to include and exclude just to follow the neutral guidelines of GitHub. So if you were to do whitelist, it won't work. It would say, got an unexpected argument, just change it to include. You can see now this is only training these three models instead of everything. The results would be same. So random forest 8397. If I see random forest here, 8397, right? You would reproduce this result even 3 years from now because you have passed the session ID 1 to 3, right? So as long as you have passed it, it's almost guaranteed that you can reproduce the result as long as operating systems are. Okay. So compare models are very good. It gives you a good starting point. The function that you would find yourself using the most is create model, and as the name says, create model creates the model, right? And in this case, I'm passing LR, which is very obvious that I want to train logistic regression. And if I do that, this would print another table, which is basically a score by fold, right? 10 folds, and then their means. And if I go and match this 8959, it would match with this because this and this is the same thing, except that this is the average score across the fold, and this is the results by fold. Why do you need it? Obviously, like if you're doing it for a long time, you would know that you would care a lot about standard deviation of folds, right? Especially if your data sets are not too big. Cross-validation is not the ultimate truth. At least I don't consider it as the ultimate truth. Okay. This is a fold parameter in create fold. By default, it's 10, but you can change it to 5 fold. So in this case, I have trained the decision tree using 5 fold, and my mean accuracy on 5 fold is 750. Okay. Similarly, random forest. Okay. So and obviously there are other parameters in the function, but I'm not gonna go through them as they are very self-explanatory. So if you just do Shift Tab, we take extra care that our documentation is in English. So you want, so let me read this. This function creates a model and scores it using stratified cross validation. The output prints a score grid that shows accuracy. So we have, as much as we have taken time in developing this, we have taken almost a similar time in making sure that our documentation in the library, on the website, all the tutorials, they are for people who can work in English, right? So it's very simple in that sense, and I encourage you to read it. Okay. Similarly, there is a function called tune model, which kind of, as the name suggests, very obvious, tunes the parameter. So here I have created a logistic regression model, create model LR. 8959 was AUC. Now I am tuning. I'm passing that LR inside my tune model function. What kind of tuning it would do? We have a random grids behind the scene. It would iterate randomly over those grids, right? So sometimes performance improves, sometimes it doesn't because it's a random grid. Okay, so you can see 89, 20, 59, 89, 27. So it didn't improve, right? It didn't improve in this case, but because it's a random grid, you can increase the number of iteration. It would obviously increase the time it takes to iterate over the values, but it may sometimes result in better outcome. But in this case, it didn't. Okay. Let me also try a random forest. So my pure random forest was 8544. $87.41. So improved in case of random forest, but didn't improve in case of logistic regression. Normally, I have seen that hyperparameter tuning would work better with tree-based models. Okay, and if you see the object that you get back is basically nothing but the same object that you were used to working with scikit-learn, right? So, for example, if I create logistic regression, and it would give me an LR back. So this object, right? And if you're interested in coefficients or anything like that, you have all those attributes still available. So Pycaret is not an abstraction layer. You still have those original attributes and methods of scikit-learn available to you, plus you have more things from Pycaret. So it's not abstracting anything, right? It's not abstracting anything at all. You can use those methods that you are used to, okay? Okay, similarly, there is a function called blend models, stack models. I'm not gonna go through them, but as the name suggests, blend models take more than two models inside and just blend them together. So basically create a voting process. A stack models is a stacking process, right? We have also this analysis functions, which is basically plot model, right? And plot model, if you run plot model, you see the documentation of plot model. There are 14 or 15 plots available, all these, and we are adding them continuously, right? So 6 months from now, you may have like 40 plots or something, right? But all the common plots that you would need, AUC, confusion metrics, and things like boundary plot, right? Things like this, right? So you have all those plots available. Feel free to check on your own time. There's a function called evaluate model, which basically gives you a nice UI for all the plots. So basically, this is the default hyperparameters of random forest. This is the AUC plot. This is the confusion metrics, precision recall, lift chart, gain chart, error, class report, feature importance, precision boundaries, everything, right? Okay. Interpret model is basically implementing Shapley values, so more for the interpretation of your tree-based model. So in this case, I'm creating a get boost model and passing it inside interpret model. It would give you a nice visualization. And these are the sharp values on your x-axis. The colors are denoted by feature value, high and low, and these are the list of your features. So similar to feature importance, a little bit different, but if you don't know about it, read about it. Sharp is an excellent framework. There's a little bit of learning curve involved. There's a lot of maths that go behind the scene, but you'll find enough material on internet to understand what this graph is showing. Okay, but it's really cool. If you haven't used it before, I would encourage that you read about Sharp. And there are similar frameworks like Sharp, like ELI 5, and Microsoft is doing a lot of work. Their Interpret ML is the framework Microsoft, I think, has recently released, and they're doing a similar work maybe on the similar ground, I would say. Okay, Automl function basically does nothing but all the models that we have trained so far. It would keep a track of all the metrics and bring you the best model based on whatever you ask. So in this case, I'm asking optimize recall. When I run this is basically logistic regression with a C of 5.560005 is my best model, right? And let me show you what happens. So this is my MLflow server, right? Let me just press F5. Here's what happened. So by this time, when we were training all these models and doing everything, it has basically recorded all these models, these things, with their metrics and parameters and everything else, right? So let me just go into logistic regression. This is the same thing we have seen, right? In Python, this is the best model. C is equal to 5.56005. All the other parameters, metrics, other details, and the model itself. And this is not just the model, but it comes with the YAML file, pickle file, and all the bells and whistles, right? So basically, after this point, you just you deploy it like in seconds. There's nothing much you would need to do, right? Okay, I've left these functions in the notebook so that so we haven't seen how to predict on the new data set yet, right? So let me create a logistic regression model. There is a function called predict model, which is basically used for predicting the metrics on holdout. In this case, I'm predicting the metrics on holdout because I'm not passing any new data set. So by default, it would assume that I have to predict on holdout. So this is my result in holdout. My cross validation was doing 89 holdout. I'm doing 90% AUC. Not a big overfitting or underfitting. Maybe this is fine, but again, the data set is only 700 raw, so cannot comment. But the point being that it would basically give you the predictions, okay? And you would see label and score. The score is predict proba in sklearn, and label is label. Okay. Now, if you were to pass the new data, in this case, I'm basically mimicking. I'm copying my existing data, dropping my target column, and then passing into predict model. You can see data is equal to new data. I want to show you something. You see, you still get back your original data with two new columns. So this is a human readable output, right? Because if you see store 7, yes and no, this is not one hot encoded. Behind the scene, we have done all those work, but when we return the output, this is a human readable output with IDs and everything else. So you don't need to do any post processing. Okay. You can save the model. So I'm saving my best model. I'm loading it back And when I load it back, I can show you it's a pipeline. It's not just logistic regression model, it is the entire pipeline. And if I were to visualize it, this is all we have done. Now you'll see there are a lot of empty boxes because we didn't do a lot of things in pre-processing, but you can do up to like 25, 30 features out there. And we are continuously adding things in pre-processing pipeline. Okay, with this one word, deploy model, you can literally deploy the model on cloud. So here I'm deploying my model to AWS into my bucket called Pycaret. If I run this, it says model successfully deployed on AWS S3. And now don't be surprised. Let me open my S3. This is the model, right? And imagine this is my computer, but imagine, like, let me just mimic the scenario for you. Now somebody in his or her notebook would basically do this from Pycaret.classification, import load model and predict model. This is on the inference machine, okay? And then you would just do load model. Let me get the name. This was the name, best AWS platform authentication, blah, blah, blah. Right, this was, so I've just opened a new notebook, just loaded that model from AWS, and this is the model. And imagine this is my data set. Let me just load in the new data. I obviously don't have new data, so I'm going to use the same data. And I'm going to drop purchase access 1 in place is equal to 2, new data.column. Purchase is gone. This is my new data, and this is my pipeline L. So what I'm going to just do now is predictions, predict model L, data is equal to new data. And if I show you predictions, this is my new data. Obviously you would have your new data. I just copied the same data, and this is your prediction and your label and your score. So basically this transaction is CH with the 34% probability, right? Got the point. Okay, that was on classification. Now I realize that we are really out of time. What I'm going to show you. So this ML flow interface that you have seen, you might not see a lot of value in this when you're working on your own computer. You would say, well, I'd rather just keep a track of notebook rather than maintaining something like this, right? But the reason this is extremely powerful is because I don't know if you realize that at every step, this is not just saving the parameters or metrics or let's say in case of tuning, it will also save the iteration grid, which is basically what were the parameters and what the score. This is our iterations when we do the tune model. It would save the result and hold up, which is similar to what you see in Python, but it is also saving model and model.pickle. So it's not just model.pickle, but the entire transformation pipeline it is saving, right? So basically, if I open another notebook and just do this from Pycaret.classification, import load model, right? And just do this, ASD load model. See, this is at the moment is my hard drive, but when you actually set up this, you would set up for artifacts, you would set up some kind of S3 account. For database, you would set some kind of MySQL database or Postgre. So that's the power. Imagine you have a team of like 50 people working. So now all of them are logging their experiments in ML flow. And you also get, at the moment I have hidden version and user, but basically if you're working in a big team, this is not just your version control, but it's also like it's a central repository, right? Now even better, because we are moving from doing all these things ourselves towards more managed platforms, and Databricks is one of them, right? So here I have my cluster right? With Apache Spark included, and it's a very simple two machine cluster with 14 GB memory each. I'm gonna open a new notebook. Okay, I just want to show you. I'll open a new notebook, call it test 99. Let me just import version of Pycaret to see if it's already there, 2.1.2, right? And now let me do the same thing. From Pycaret datasets, import get data. Data is equal to get data use. As you can see, I mean, obviously this Databricks notebook doesn't have IPython. That's why it's not looking beautiful. It's similar to how it would look in Spider or this non-notebook environment. So it's similar to that because for some reason it doesn't use IPython. Anyways, from Pycaret.classification, import all setup data target is equal to purchase. And two things that you need to take care of when you're not working in notebook is you have to pass HTML is equal to false so that it doesn't fail, and silent is equal to true, right? Let me just run it. I forgot to add log experiment to experiment name. When you are working on Databricks in Azure, you have to pass, you cannot just pass say ASD. You have to say full name. Full name include users, your email address, in this case my email address, and then the name. So let's say DataQuest is the name. Right, and you can see it's exactly the same thing except that it's not beautiful looking because it lacks the HTML formatting. But the point I want to make is, let's say your team is using Microsoft Azure, right? You normally have managed services on one of the clouds. So we are using Microsoft Azure. Pycaret is installed on a cluster. I load it in my data. I'm loading it from Pycaret repository. In real life, you would ideally connect it with some kind of Azure SQL PaaS instance, or even if you're reading CSV, you would read it from a blob storage or AWS S3, or depending on where your data is stored, right? But to make a point, I've just loaded in the data set from repository, and I am now creating a logistic regression model. And let me also create a XGBoost model. You can see it's exactly same thing except that it's not formal. Okay. XGBoost model, and also create a GetBoost model. Okay. And what was the name of my experiment? DataQuest. Okay. The point I want to make here, so now because you don't have any local host now, right? Because you're working on Azure cluster, so you cannot just open localhost 5000 because these experiments are not logged in your computer. Now it's logged on managed services. So here, and if you're using Azure Databricks or just directly Databricks community version or anything, you would get it's all the same. Okay, it's just the resources behind the scene here is from Azure. Okay. And if you would see in here, here you see I have a DataQuest experiment created, and if I click on that, you would see this is exactly same page as you have seen here in my local computer, except that this is localhost 5000. It has no value if you are working in team unless you make your localhost accessible to other people. That's how companies who don't want to go to cloud, that's how they would do. They would install a server locally, install everything, put a artifact store behind it, put a PostgreSQL database behind it, and expose it to on the network, right? But normally, like, people are moving to cloud, so I don't see that as a long-term problem. Anyways, here you can see our artifact storage was DBFS. So Azure has, behind the scene, I have my resource group connected to Azure, so it was using that, and it's exactly same thing. Let me just hide the parameters. So it's exactly the same thing, except that now imagine you have 50 people in your team, you would see their email addresses as well, right? Now you see at hotmail.com because this is my personal account, but you would also see the source, right? So it would actually take you to the script as well. Anyways, that's not the point. The point is, now imagine your DevOps team and data science team, they are working here. You have ability to write notes, right? Which is really cool. You can write notes and use this as a documentation management thing. But one thing that I want to show you here is your DevOps engineer and data scientist is working in one team. You identify your experiment by the name of experiment. Multiple data scientists are doing bunch of experiments, and here are all the models logged. And now your DevOps engineer would come and see the notes if you have any notes. Let's say we had a note in get boost classifier, note for DevOps, date, blah, blah, blah. Promote to production, save, and your DevOps would come and see here, okay, model, register model. Create a new model, let's name it DataQuest model, register. Now what it is doing, if you click here, now it is basically creating a repository. So there's a models function here. Now it is basically creating like a repository of models, maintaining the schema and everything. And basically you can come here, you see all your models and if they are in staging or production or what and what not. But you can also go to serving, enable serving, and it would basically create a REST API endpoint automatic, right? So no server, nothing. It's just, it took me 5 minutes this morning to create this workspace for Databricks, right? So point being that it's not as hard as many people would think. Right, you can see this has started doing that. You would get a sample Python script, curl, or from the browser or whatever, right? Okay, let me see. Okay, so in the presentation, if there are, after the thank you slide, I have included a lot of resources which include notebooks, videos, tutorials. Feel free to check them out at your own time. Also, there are other notebooks. So we have covered classification one, but you can see we have regression, clustering, anomaly detection, NLP association, and they are all exactly same. So you wouldn't need to learn anything new in terms of coding, but obviously they differs in their how the supervised and unsupervised learning is done, right? Theoretically, they're different, but you wouldn't have to do a lot of different things in Pycaret to achieve that. Okay. So with that, let me open the floor for questions. So what I'm going to do is I'm reading the chats and answering questions. Where does question start? Love your online content. Daniel, thank you so much, Daniel. Can Pycaret be used in R or only in Python? Now it's only in Python, Danish. Is there a link to the slides? Yeah, the presentation is also uploaded on GitHub. And I think somebody has posted the link. Thanks, Christian. Ritik. Its application are same as any other machine library asked by Preeti. Yeah, Preeti, it's just it's a application and everything else is same. It's just a different library to train your models. LinkedIn. Pawan, sir, this data doesn't have NAN, but if there were, how would we know what method of implementation were used? Very good question. So let me put my screen again on share, and let me show you one of the notebook. So here, if you can see my screen, yeah, you can. When the information grid is printed, do you see this? Numeric imputer, mean, categorical imputer, constant. If you see the documentation, there are a couple of methods you can choose between mean and median for numeric imputation, constant and most repeated, most frequent value for categorical imputation. In the next release, we have also included our own implementation of iterative imputer, which is similar to mice in R. Okay, so that's how you know, and also in setup you can change this basically. So by default you would see numeric imputation is set to mean, you can basically do this. Numeric imputation is equal to median. Now, if I show you this, median. Okay. All right. Community group grade. Also, the data type for data, is it only in type data frame, or arrays or list are also accepted? So if you are asking about the type of the data variable, it has to be a pandas data frame up until this point. In future we'll have support for Dash clients, but pandas data frame. So it doesn't work with the sparse matrices directly, if you're asking. Can we get the details of presentation? It is uploaded on the same GitHub link. Why should someone use Pycaret over other modules? Good question. It saves time, and time is money. Thank you, Kavita. Shubham, what was the motivation behind creating Pycaret? So last year when I was going through my graduate school, and I don't know if you realize that now the inflow of people coming into data science, 50 or 55% of that, more than that, is coming from non-technical background. It's not like until 10 years ago, it was very true that people from computer science and statistics would just convert into data science, but now it's no more true. And when you have people coming from non-technical background, I think the tools out there are great, but still I don't think so that data science, or in general, we are matured enough to kind of provide user-friendly solutions. So I think while tools are great in open source environment, nobody has up until I think thought about making it user-friendly solution, right? So that was one motivation. And other, I think we really waste a lot of time in coding. And I don't know what is there to brag about coding, but I think when we are solving problem, we shouldn't be worried about how do I do k-fold or stratified code. We should be able to do it as simple as what I've shown you in them, right? There is no point of wasting time in writing and maintaining boilerplate code. Is coding important? Absolutely, yes, 1000%. But should we waste time every time we are coding machine learning experiments? No. What about using Pycaret on Google Colab? So Christian, exactly the same way. So if you were to go on our website, let me open it. But basically the same way you would work on Jupyter Notebook. So you can use Google Colab or I would say, what was that? Blazing SQL. There are so many other options. Kaggle notebooks. It just works fine. Yeah, with all of them. Can we use Pycaret for time series cases? Hussein, that's a good question. So at the moment, because Pycaret does k-fold stratification, and it involves shuffling the data set, so you cannot use that if you think from the regression point of view. If we are shuffling your data set, then you cannot use that for time series. But in the next release, we are providing, when I talk about flexibility and customization, that's actually what I meant, that in the next release, we are providing all those options to users to select it. So basically, if you have a time series data set, what you would do is set the shuffle to false, so that we don't shuffle your data set, and we do a time series split into train and test instead of doing a random split. And then instead of using k-fold, we can use time series split, which is a rolling window split that you normally use for time series. Other than that, if you have a date in data set and we are not shuffling, and we are doing a time series split instead of k-fold, then basically you extract the features out of date and put it through XGBoost. That would be that can be solved by time series, right? But again, we don't have those classical ETS, TBATs, those kind of models. But I don't see any reason why you can't use them, because if they are also following .fit.predict, you don't need to use only Pycaret's model, right? You would just from stats models import ABC, and you would just pass create model ABC. Okay. Pycaret is the end of traditional data science. I don't know, and I don't know if it's the only one that is simplifying. We are simplifying for end users, but you would see most of these companies like Microsoft, Google, they all have at least one end-to-end UI facing solution. How good or bad it depends, but again, they're not open source. But I appreciate that. Thanks for creating such a simple, fast, and useful library. Thanks, Anubhav. By the way, you're just reading this fast. Next version would also have an integration with fast API so that you can deploy your endpoint on your local machine as well. Tejas, do we have any visualization function? Yeah, there is a plot model function in classification in all the modules basically, and I think we have a very good collection of plots. Very good collection of plots. And if you think something is missing, feel free to open a issue on our GitHub, and somebody would address it. So basically the architect behind the scene allows us to expand horizontally very fast. So if you think there is something missing, so for example, somebody in the last release pointed out gain and lift curve, and we just added. Any plan for running model with a Spark, Farhad? Not with the Spark, but we're trying to go in the direction of Dask, which is more Pythonic, I would say. But it's the same thing, right? You can scale on multiple machines in a cluster. Thank you, Corey.
All right. Thanks, Moez, for joining us today. It was a great session. I guess the only person jealous after seeing this library would be Jeremy Howard and his fast AI functionalities that you have kind of introduced into your stuff. So, do you plan of like introducing deep learning as well in your Pycaret library?
I don't know. For some reason, I get this question a lot. Do you plan to include deep learning? As of now, I don't think so. I think deep learning is its own area, and there are some people who are really doing cool work in deep learning. So I don't think so. We need to scratch the surface of deep learning at this point. But who knows what's in future?
I believe in the recent upcoming years, yours library is gonna be one of the most used library on competitive platforms like Kaggle and other platforms where people would be churning up notebooks on PyCaret and not on sklearn and XGBoost, etc. So thanks for
Mhm.
joining in today. Just before everyone leaves, a few things.
Nice. Thank you, everyone.
Yeah, sure. Thanks for joining in. So, guys, thanks for joining us. Don't forget to follow our handles for more such great content in future. And we have a dedicated study group for AI and machine learning and deep learning. You could join in us at dataquestai.slack.com where we have more great people around there. And if you guys have any queries related to this session or any other session that is uploaded on our YouTube channel, etc., you guys can reach out to us on info@dataquest.vision or on our Telegram group. Also, a special thanks to Moez for joining us in the session today. Thanks, everyone.